Hi, my name is Miranda Pierce, and I did my final project on Amazon Web Services Elastic Beanstalk with a .NET application. To give you a summary of what this service is, it's a platform as a service on top of AWS's infrastructure as a service offerings, which include EC2, S3, simple notification service, CloudWatch, load balancing, auto scaling. So everything you need to launch a website, basically. A developer uploads application code, provides some environment details, and within minutes, Elastic Beanstalk will handle server provisioning, load balancing, scaling, application health monitoring, and it also helps manage some of the versioning. Also gives you a pretty URL by default, and then they charge you just for the underlying services that you use. The application types that it supports are Java, PHP, .NET, Node.js, Python, Ruby, and here are the details for .NET because that's what I was focusing on for my project. So there are a couple of server versions, IIS versions, and language runtime. The components of Elastic Beanstalk are application, which is your highest level of the component. And within that, you can have multiple versions, and that's a deployable set of code. So it'll be a WAR file if you're in Java, or a zip file if you're in .NET. You also have multiple environments. So you can have a development environment, test, prod, whatever else you might need. Each environment has a set of configurations associated with it, and then you can also save that configuration as a template in case you want to use it again. For my final project itself, I just needed a website, and I have a friend who's an artist who has been working on reviving an heirloom strawberry that was on an endangered, I don't know if it's a species, if it's a plant, but an endangered plant list. So she's been cultivating this strawberry that's supposed to be really delicious and sharing the runners with other people, selling the runners. And then she wanted to create a community site that would be a little easier for her to manage, so that those people, when their plants mature and they have runners, they can sell them or give them away to other people. So I thought that was a good starting point for just to have a goal for the site. Let's take a look at what this looks like in the management console. So this is the Elastic Beanstalk homepage. I have one application, Marshall Strawberry Web, and I have 3 environments. So if I go into my application, here are my 3 environments. I can go into any environment and I can edit the configuration of, for example, the scaling or the size of the instances, or I can enable rolling updates. I can also see logs, monitoring, alarms, and events. I can also see all of my versions for this application. In this case, I have 2 versions. You notice the name of this says Git. I'll show you later how when we deploy from Visual Studio, it actually creates a local version of Git and deploys from that. So that's how it got this name, Git, instead of like marshallstrawberry.zip. I also have saved configurations. These aren't automatically created, but once I have an environment, I can create a configuration, and then I can make other environments from that configuration. So I mentioned that all of these applications are provisioning other Amazon services. So if we take a look at the environments, those are a bunch of EC2s and load balancers. So if I go into my instances, EC2 instances, here they are. Each one has a load balancer with a minimum of 1. So they each have 1 because they have basically no traffic right now. I can go into load balancer, and here I see 3 load balancers. And if I click on one and look at the instances, here's my load balancer for Marshall Dev. In addition, we also saw that we have 2 versions of our application. These actually get stored in S3, and if we go to S3, we can go into our Elastic Beanstalk bucket, and here are the instances. It dumped a few more in here from when I was playing around, but my 2 Git instances should be in here as well. In addition to the AWS Web Console, there are also plugins for the IDE. These are the same plugins that you've probably already used for the other tools. I'll show you the Elastic Beanstalk features for Visual Studio. You can also manage it programmatically through the SDKs for Java and .NET. I'm going to show you a little bit about the SDK for .NET. In addition, there are also command line tools, just like there have been for all of the other services. They follow a similar pattern. The EB command line interface is their newest one, and it actually is a little different than the other ones that we've seen. It follows a Q&A format, and it also integrates with Git. The second one, the Elastic Beanstalk API, is much more like all the other command line tools that we've seen. And finally, AWS DevTools is a Git client and extension. When you launch an environment, Beanstalk needs several details in order to create it. It wants to know what the environment tier is, if it's a web or a worker. I'll tell you a little more about the worker. It's kind of a new feature. They want to know what platform this is. Is it going on IIS, Node.js? What the environment type is. Is it a single instance or load balanced? And what application version you're going to use. I showed you can have multiple versions hosted in your application. They want a name. They want to know how big your EC2 instances are going to be. Let you give a key value pair, an email address for notifications about your environments, a health check URL for the load balancing auto scaling. It lets you put it in a VPN, and then it also wants to know if you're using an Amazon relational database, and it will configure the security so that your EC2s and possibly your local environment, if you're doing all of this through an IDE, it'll configure it so they have permissions. Now I'd like to demo for you how publishing a website from within Visual Studio works. So here I've already installed the AWS plugin, and you can see my AWS Explorer window here. I already have one application. I'm going to refresh this. I already have one application with 3 environments. And I also already have a website solution. So I'm going to use this existing website solution and just deploy it as a second application. It'll actually be identical to my first, but that doesn't matter for these purposes. And if you want more instructions on how to generate the website in Visual Studio, like a Hello World or demo website, and how to deploy the database itself to the Amazon relational database service, my final project paper goes into that in more detail. So here's how you do it through this. No. Okay. So I right-click on my project and I say Publish to AWS. It already has my account information, and I don't want to redeploy it to my existing application. I want to do a new one. So I say Deploy new application with template, Beanstalk. And I'm going to call this Marshall Strawberry Web 2. I'll just give it the same description. And I need to pick a first environment. So maybe we'll call this Marshall Dev. Environment. And I want this to be load balanced and auto scaled. And here you notice the environment name also is being used as the environment URL. And I can check availability. And it's not available because I'm already using it for my other application. So I'm going to call it 2. And I'll call this 2 also. They don't have to match, but it's kind of simpler for me if they do. Now I get to pick the container type. I'm going to pick the newest. That seems fine. I'm not going to provide a custom AMI. I'm going to say micro. I'm going to pick a key value pair. And I'm not going to opt to use a VPN right now. My target framework 4.0 sounds fine. For my health check URL, I'm just going to use the default page, which is /. I'll give them my email address. And actually, I am using a database, and I'm going to select that one so that my application, when it's deployed, can use the same database that my other sites are already using. Gives me a summary of all the details, and I say deploy. So now it's going to take a couple minutes, but what we will see is if I go home, see, has it refreshed yet? It'll take a couple minutes, but eventually you'll see it here. So that took me like 2 minutes, and the site is launched. Through the magic of time-lapse, I can now see that my second application is up and running. I can go into that application. I just have the one environment that I started, and if I click on that, it gives me the URL, which we had already seen that it was going to use, and if I click on that, I can see my application. It's just like a hello world that uses a database. Once you've launched the site, there are a few more parameters that you can control that we didn't see in the Visual Studio interface. Most of these ones I've listed here are the same, but I can change the auto scaling min and max. I can change availability zones, cooldown, the size of my instances, the EC2 security group, notifications. I can enable rolling updates, which means that when they want to update my EC2s, they'll take one down and update it, then the next, so the whole site doesn't go down. I can tell it that I want to have sticky sessions in my load balancer. A few other things. I mentioned earlier that we had a choice in environment tier between web role and worker role. So far, we just looked at the web role, and that's still going to be their default, but as of about 4 days ago, they introduced a new environment tier, which is worker role. And this is very similar to the Azure Web Worker Services. Both tiers are websites, though, in AWS. The worker doesn't have to implement a specific API like it would in Azure. Instead, the AWS worker will receive a post to a URL that you specify. So when you create the environment, you say, here's the URL I want you to post to, and Amazon will watch a queue service, and it will forward requests to that URL for you to process. And then when it receives a 200 response, it'll remove it from the queue for you. So they remove a little bit of the overhead. Most tutorials on the site still don't have much information about this. For example, it's a little hard to figure out how you would debug this locally. So, you can look into it. I expect they'll have more information soon. In addition to the environment fields that we were asked for when we were deploying an application in Visual Studio, you can also create a custom configuration file, and it's just a YAML or JSON format file in with your source code. And in it, you can tell Amazon to download and install prepackaged applications and components. You can ask it to download and unpack archive files and put it on your EC2. You can generate files with content that you might have in your config file. In Linux, not in Windows, you can also create users and groups. You can run command line commands. You can run commands that only happen after everything, only after your application and web server are set up, such as start or stop services. And you can also set environment variables. So these are ways to further customize the environment, which otherwise is pretty limited. Another aspect of the environment you can configure with these config files is you can provision resources. So instead of manually going and creating a queue service that maybe is going to be used by my worker role, Here I can create a config that will generate the queue service when my web site is deployed. We already saw the web management console, and we saw the Visual Studio IDE plugin. Here's an example of one of the command line interfaces. This is one that's really analogous to the command lines we've seen for their other services. So here I'm calling the Elastic Beanstalk update environment executable, and I'm saying for environment, I want to update Marshall prod. And for -L, that's the version label, I'm going to say I want you to use git b11 blah 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 blah. So I execute that. It will have to redeploy, so the site will come down briefly, but that works. A lot of the features we've seen in Elastic Beanstalk sounds kind of like AWS CloudFormation, and it's actually just one step more automated than it. It uses CloudFormation under the hood, and everything you do in Elastic Beanstalk you could also do in CloudFormation, or for that matter, you could do directly creating EC2s, load balancer, auto scaling, and security groups. Where CloudFormation has you create templates with AMIs specified, Elastic Beanstalk, you don't have to do that, but you can do some of what you can do in CloudFormation. Here's what it looks like when I've got, previously I had one application with 3 environments. If I then switch over and look at CloudFormation, this is what it looks like. I can see I have a CloudFormation stack for each environment. And here when I select one of them and I look at the description, it references the Beanstalk environment. What can Elastic Beanstalk not do? It allows you to customize, but not entirely. It supports configuration to use some older versions of the stack, but not a ton of control over the exact environment. It also only supports one WAR file or one zip file, and that file is limited to 500 megs. Updates are a little funny. They are going to update these environments. They're not going to update the ones that are already up, but if you launch a new EC2, it's going to, or if you launch a new environment, it's going to have the latest updates. So you have to be a little bit careful about, you have a little less control over the updates. Who should use it? I think this is probably ideal for kind of lightweight developer-owned projects, maybe startups. A lot of the case studies on the Amazon site seems to be profiling startups, who want all the scaling, but maybe they don't have a large staff and they don't need or want total control over every aspect of the site. Similarly, if you were working with an organization that has really strict IT oversight, I think IT might not like this because they might want more control over their AMIs, like what's installed exactly on these AMIs. And they may want to update the schedules, schedule the updates themselves. Competitors and alternatives. Google App Engine, platform as a service, would be another option people might end up using, Heroku or Engine Yard. So those are who they're competing with. If you'd like to learn more, there's a lot of documentation, an intro, walkthrough, and tutorials with sample applications for every language up on the site. The .NET tutorial uses the Nerd Dinner application, and I actually ran into some problems getting it running. So you're also welcome to use the instructions in my final project.